Hello, we are from Group 3. Today, we as a group would like to present regarding our project, which is Find a Gene Project. We are a group of three, consisting of Ami Iskandar, Iman Hassan, and myself, Naveen Trarao.
Okay, so first its introduction. There are actually several ways we can perform computational analysis. Some of them are Biopearl, BLAST, Betul, Cluster Omega, Emboss, Bioinformatics Tool, Linux, and IGV genomic sequencing tool to find the novel gene. Novel genes are classified by their age. Genes that emerge within a selected time frame are novel genes. Clade is a monophyletic group or known more as a natural group that originates from a common ancestor and or its linear descendants on a phylogenetic tree. The novel gene that is determined with the percentage of identity which is less than 100% and the e-value that is less than e negative 30. Phylogenetic tree that is known as phylogeny is a diagram depiction. It is used to visualize which sequences have the same ancestor. The gene of interest that we decided to pick up on is on insulin mutein REMT. It is actually the scientific name for BAT. It has the accession number of XP014388588.1, which came from mutein branch BAT. Next, for the process 2, we perform the T-BLASTAN search against Homo sapiens ESD. Next. Sequence alignment is a method or a step of arranging the sequences of DNA, RNA, or proteins to identify the regions of similarity that might pose a consequence of functional, structural, or evolutionary relationship between sequences such as listed above like DNA, RNA, and as well as protein. Sequence alignment can be stored in a large variety of text-based file formats. Some of the text-based file formats are such as FASTA. There are two types of sequence alignment. One is global alignment, another one is local alignment. Sequence alignment plays a very crucial role. It is important to find functionally similar regions within protein, and it is important to predict new members of the gene families. Next. The parameter that we of the T-BLASTers that we used along with its settings. The max target that we have adjusted is set to 100. The expect threshold is set to 10 instead of 0.05, which is the basic default. And the word size is set to 6. And the max matches in a query range is adjusted to 0. And the metrics we use is Blossom 62. And the gap cost is set with existence 11 and extension 1. And the compositional adjustment we adjusted to conditional compositional score matrix adjustment. And the filter we used is flow complexity region. Next. So after the search is done, the other information shown on the BLAST search, such as accession length, total score, query cover, accession number, and percentage of identity. The percentage of identity indicates the similarity between the query sequence with the target sequence. The high resulting percentage of identity indicates that the query is able to be matched very well.
For the part 3, which is gathering the information about the novel protein, basically in the result of the BLAST search above, basically we found a match, we choose a match, were chosen on the low e-value and percentage of identity less than 100%, which is the accession number of BQ26728. So basically with the 52 percentage of the identity, 2E18 for the e-value, and yeah, a 405 base pair were chosen from the Homo sapien. This sequence has the possibility to be the novel gene. Hence, to prove the hypothesis is true, basically the more detailed analysis will be performed to prove this hypothesis. Okay, for determine the gene whether it is a novel gene or not. Okay, next slide. Okay, basically need to be conducted using the sequence obtained from the step 3, the previous step, where the first condition is to check whether if the match with a less than 100% identity, it is likely that the protein is novel. And yeah, the second condition is that if there is a 100% match with the identity, but the protein belong to a different species than the one that we use as a query, then it is a novel gene. Okay, let's look at the graph below. Basically, from the experiment that we did, the search that we did, a list of sequence that have a significant alignment was obtained. Basically, the distribution chart shows that all of the sequence have functional part that cover the whole sequence. Basically, based on the result that we search, multiple sequence have been found belonging to the different species with a less than 100% identity. Therefore, the protein sequence that we found basically is a novel gene.
So for this, So for the step 5, we are doing the multiple sequence alignment. We are doing this multiple sequence alignment from the result that we have obtained from the BLAST research that we do in the previous step. So we have chosen 8 sequences to do the multiple sequence alignment. We doing this alignment using the MAF from EBI website. So we have selected a total of 10 sequences which we will use to do the multiple sequence alignment. These sequences includes the original gene of interest, which is the insulin Biontis brandi, and the novel gene that we have found. So this is the result that we have obtained from the MAF multiple sequence alignment. Step 6, we have generate a phylogenetic tree based on the sequences that we have selected from the previous step. So we doing the phylogenetic tree using the Mega software. We just open the FASTA file into the Mega software, and we build a neighbor joining tree using the Mega software. And the picture in this slide show the result of the phylogenetic tree. For the conclusion, we have seen that this novel gene can be found at the human pancreas, which is the part that produces the insulin. We also found that some of the species which are the chimpanzees, orangutan, gelada, and olive baboon, they share the same ancestor as humans. Because this can be seen by the phylogenetic tree that was produced in the previous step. The difference between the novel gene and this other species gene have evolved more than 2 times, as it has more branches from the root. And in conclusion, the phylogenetic tree shows us that all of these sequences are related to common ancestor, and the genes has undergo evolution through the time. That's it for our presentation. Thank you.